Okay, good morning. So let us start today's lesson. For the people who are in math specialization, I have actually assigned you a homework. The deadline is today. There's just one test. I'm testing an idea. Please do it, okay? Yes?
So was every alternative wrong?
No.
No, because...
No, that's that. I'm just trying to see how it works, but I think I did it correctly because already 4 people assigned that, and I think they had the correct answer. Yeah, but I will give up that one. I find a better way, so we'll do that later. I just want to test this idea if it is working because it will automatically correct your papers, and it would be very good if I can invest that. Okay, so let us start the lesson, and I think you are very lucky that you start your day with mathematics today, yes? You feel excited, yes, it's clear. Okay, now let us continue our lesson. So we talked about the trigonometry and the unit circle, so if I just want to refresh your memory immediately, fast. So this would be the unit circle. The unit circle by definition is a circle whose center is at the origin of this coordinate system and its radius is 1 unit of length. Yes? And then I told you that here we have a positive direction. So here, by the way, is the origin of the unit circle. And then if you go counterclockwise, it is a positive, this is the positive direction, and the other way around clockwise, it's the negative direction. And then if you have in trigonometry, the difference between a trigonometric angle and a geometric angle is that in geometry, angles are between 0, the lowest value is 0 degrees and the highest value is 360 degrees. But in trigonometry, we have also negative angles. We can have angles greater than 360, whatever you like, yes? And then I think you remember that I told you that if you have an angle, you always start from here and start rotating appropriately. If its angle is positive, you rotate in this direction about the origin. Or if this is negative, you start rotating in this direction. Even if it is more than 360 degrees, you just go around and around until you finish, yes, and then you stop somewhere. It doesn't matter how big your angle is. It doesn't matter if it's positive or negative. When you do that, you end up somewhere on the unit circle. And when you end up somewhere on the unit circle, there are 2 coordinates with this point in this coordinate system. One of them is x, the other one is y. And then if your angle is called theta, we define sine theta to be the y coordinate, and we define the cosine theta to be the x coordinate, and then we define tangent of theta to be y divided by x, but of course in this case x shouldn't be equal to 0. If it is, tangent is not defined. And I don't want to review all the things that we actually learned. We learned one of the most famous formulas for trigonometry, and that was sine squared of theta plus cosine squared of theta is equal to 1, regardless of the theta. So that was a famous formula that we have. And then we also learned what is the connection between sine, cosine, and tangent. So we learned that this is sine theta divided by cosine theta. So I recommend you to send these to your memory. It's very important to have them. Of course, you will get them in the formula sheet, but it would be really distracting if all the time you want to refer to the formula sheet for every single formula. Okay, and then, for example, we learned that sine and cosine and tangent have different signs in different quadrants. This is the first quadrant, second quadrant, third, and fourth. So in the first quadrant, sine, cosine, theta, tangent are all positive. For example, in the second quadrant, the x-coordinate, which is cosine, is negative, but y-coordinate is still positive. So sine is positive, cosine is negative. So consequently, tangent should be also negative because you are dividing a positive number by a negative number and things like that. We have already summarized that. And I try to give you some examples so that you can learn the idea how to work with symmetry, arguments, and the unit circle, which was very important. Now I want to formalize this today as a set of formulas, okay? These formulas are not probably given in the formula sheet, but it is in the box in your book. I just want you to understand them, and when you understand them, you can find them whenever you need. Okay? So let us start with this title. So I would write it trigonometry of the opposite angles. Okay, so what I mean that as I have an angle, I want to see how sine of minus theta is connected to sine theta. Okay, so let me take this equality away. I want to find a relation between these numbers, if there is any relation between them. And I want to find a relation for the cosine of these angles, and consequently I want to find a relation for tangent of these angles. Okay, and I want you to discover them, because if you can discover them right now, if you forget, which are very fundamental formulas, okay? So if you forget, you can actually retrieve it again later if you need it. Okay, so first of all, do you understand? I have an angle theta and I have an angle minus theta. That would be the same amount of rotation, but in the opposite direction. Yes? I want to understand how these two numbers are connected. How sine of minus theta is connected to sine of theta. And the same question for cosine and the same question for tangent. So you need to visualize it, okay? So, for example, any clue? For example, can anyone answer the first question? Yes, someone?
Isn't it minus opposite theta?
Yes, can you elaborate on that?
Because if you move, like, for example, 30 degrees plus, so the other direction, and then you have to move minus 30 degrees.
Yeah, let me just draw something. So instead of 30 degrees, if you don't mind, let me just, for example, if theta is here, minus theta would be the same size angle but in the opposite direction. Yes? Okay, now if the coordinates of the final point are x and y, which is the only thing matters for sine and cosine and tangent for theta, I need to understand what would be the final point using the symmetry arguments that we learned in the previous session. What would be the coordinates here? Yes? So what would be the x coordinate? Yes?
It would be the same.
X, and then as Amanda said, y would be negative y. Yeah, so it would be x and minus y. Everyone agrees? Okay, now if I ask you, what do you say about this? Sine theta is y. Sine minus theta is minus y. Is that understandable for everyone? Because if you are interested for in minus theta, you need to look at the final point for minus theta and read the y coordinate of that, which is minus y. So if someone asks you what is this, this is minus y. If someone asks you what is this is y. One of them is minus y, one of them is y, so they are opposite of each other, yes? So this is the first thing that you need to imagine in your mind, and then of course realize that. So this is a new rule that you're learning. If you have sine of a negative angle, you can pull the it seems that I am pulling the negative sign out. Yes? This is valid. So we can pull a negative sign out, but that's it. If I have a 2, don't think that I can pull 2 out. Yes? So this is the thing. If you want to discover something, you need to actually understand why. So don't think that because I can pull a minus 1 out, I can also pull a 2 out. No, that's totally wrong. The only thing that you can pull out is just minus 1. Yes, that's the only number that you can pull out here. Okay, what is the relation between these two? Yes?
They're equal.
They are equal because both of them are x. Yes? So these are equal. So this is very nice. Cosine immediately gets rid of the minus sign. So cosine of a negative angle is exactly equal to the cosine of the positive one. And then, what is the consequence here then? Tangent of any angle is sine of that angle divided by cosine of that angle. So if I divide this by that, it becomes this. I can divide this by that. Sine divided by cosine is tangent, but I will have an extra minus sign, so that could be also a minus sign here, yes? Or if you don't like that, if I ask you what is tangent of minus theta, you would say that the y coordinate divided by the x coordinate, which is minus y divided by x. If I ask you the same question for tangent of theta, you would say y over x. It is clear that they are also opposite. Yes or no? Yes? Everyone happy? Okay, so it's important. I myself have them in my memory. That's up to you. But remember, you can pull a minus sign out from here and here, but for the cosine, it's simpler than that. You just drop it. Is that clear? Okay. So now, what do you think? What would be the relation between these two expressions? If I have sine of alpha minus beta, alpha and beta are angles, what is the relation between this and that? If I ask you what is the relation between these two, I think the answer is immediate. Can you, under 1 second, answer this question? What is the relation between these two? Yes? They are equal because alpha plus beta and beta plus alpha are exactly the same numbers, yes? The same angles. So it is clear that if they are the same, the sign of them will be the same. But alpha minus beta and beta minus alpha are not in general equal, yes? But what is the relation between them?
They're opposite.
They are opposite. Why? Because alpha minus beta is negative of this. Yes? If I have alpha minus beta and I multiply it by a negative sign, it becomes negative alpha plus beta, which is beta minus alpha. So if I ask you what is the relation between these two angles, you would say that these two angles are opposite angles. And whenever I have opposite angles, I have the same rule. Yes? So I can pull a minus sign out. Yes? So it's very nice. You can pull a minus sign out and swap them. But if I have a cosine, what can happen here? Can I interchange them without any changes? Yes or no? So if you cannot answer this quickly, it means that you didn't understand the first one. Did you? And if you didn't, why didn't you ask any questions? Yes? So I'm telling you that alpha minus beta and beta minus alpha are opposite angles. Do you agree?
Yes.
What is the meaning of opposite angles? It means that if you add them up, it becomes 0. When I say 2 and minus 2 are opposite, it means that when I add them, it becomes 0. Yes? So here, minus theta and theta are opposite. Why? Because if I add them, it becomes 0. So now I am telling you that alpha minus beta and beta minus alpha are also opposite. Why? Because if I add them, what is the sum? 0. Alpha and minus alpha will cancel out and beta minus beta will cancel out. So alpha minus beta and beta minus alpha are opposite angles. And the sine of an angle is minus the sine of its opposite. Because of this rule we discovered here. But the cosine of an angle is equal to the cosine of its opposite. Yes? So it becomes exactly equal to the cosine of beta minus alpha. And of course, consequently, for tangent, what do you expect? What do you expect? Minuses. So these things are immediate consequences, but you need to understand. You see, this is a formula. We write it in mathematics, but it has a soul for itself. So you need to read and understand what that formula is communicating with you. This is telling you that two opposite angles have these rules for sine, cosine, and tangent. Okay, clear? Okay. Now let me just... so this is the first topic. So let me write trigonometry of supplementary angles. You see, there will be a lot of formulas coming in. So this is why you need to have a good visualization of these symmetry arguments to be able, if you forget something, you immediately should be able to get it back. Okay, first I need to define you what do I mean by supplementary angles. So let me write definition. Angles let me know, alpha and beta are called supplementary if alpha plus beta is 180 degrees. So that's the definition of supplementary angles. In this case, we say beta is the supplement of alpha. Alpha is the supplement of beta. So I don't write it down, but this is the way that we read it. We say alpha and beta are supplementary, or we say that alpha is the supplement of beta, or beta is the supplement of alpha. Yes? For example, 30 degrees and 150 degrees. 30 degrees and 150 degrees. This is a pair of supplementary angles. Yes, because they add up to 108. Okay, for example, what is the supplement of 220? What is the supplement? Minus 40, not 40, minus 40, yes? Minus 40, because in trigonometry we can also work with negative angles. So these are also a pair of supplementary angles. 220 plus minus 40 again goes back to 180, that's okay. Now we want to discover a relation between sine and cosine and tangent of supplementary angles. If alpha and beta are supplementary angles, I want to connect them. How the sine, cosine and tangents are connected together. And I want you to do it. Discover it yourself first. And when we discover it, I write it something like this. By the way, let me put this in a box. Yes? So, what do you think would be the relation? If I give you alpha and beta, if they are supplementary, how do you think that... and by the way, can you tell me what is the supplement of alpha? What is the supplement of alpha? Yes?
180 minus.
Minus alpha. So let me just add this one in my list as well. So this is why in the book you see this combination always. 180 minus alpha and alpha, but they mean they are supplementary, okay? So my question is that, what happens if I want to calculate sine of 180 minus alpha? How this is related, if there is any relation, between this sine of this angle and sine of the angle alpha itself? Yes, I will come back to you, and then I will have this, if there is any relation. By the way, if you don't mind, let me stick to theta all the time to be consistent. Okay, so theta, it doesn't matter the name of the letter. So, and if you don't mind, let me also change this to theta. I think the book has used alpha, but I have started with theta. Let us stick to that. And then I want to ask the same question for tangent of this and tangent of that. Okay. Yes. Anyone else? Yes, please. How they are related? Yes, the first one.
So it's equal, the first one.
The first one is equal. They are equal. Why? Because if I go here, this you need to learn, because there is a likelihood that you forget or mess up this symbol negative sign somewhere. So you need to be able to visualize this if you forget. So, for example, I don't know where theta is, but let us assume that this is theta. Of course, you need to convince yourself that the argument that I am here explaining is independent of the value of theta. You need to convince yourself if you want to be very rigorous. So here, and then where would be 180 minus alpha? So this is the final point corresponding to angle theta, assuming that this is your angle theta. So let me give some coordinates for the final point. But can you tell me where would be the final point corresponding to the supplement of theta? Yes, Jonathan? No, where is the point? Just tell me where the point is. You can just describe it. Yes, it is the mirror image of this point with respect to the y-axis. Everyone agrees? So if I go here, yes, if this is a reflection of this, assuming that this is your mirror and that is the image, I want you to convince yourself that if I connect these two, then this angle is 180 minus theta. Is that understandable for everyone? Why is that? Because by symmetry, if I ask you how much is this angle, by symmetry you know exactly that this angle and that angle are of the same size, so it means that this green angle should be 180 minus theta. Is that understandable for everyone? Okay, now, so what you need to do, the only thing that you need to do is to read the coordinates of this. The coordinates of this. So what are the coordinates? It's clear that the y value is the same, but the x value is minus x. Is that understandable? Okay, and then you can discover the formula. So what would be the relation between these two? Are they equal? Because sines are y values. They are equal. But cosines are x values. So they are opposite. Yes? So this becomes opposite. And then tangent consequently becomes minus. Is that understandable? Okay, so this I put here. Okay, so for example, now let me ask you one question. Of course, you can answer this algebraically or geometrically, but let us do it algebraically. So if I ask you how sine of 180 plus theta is related to sine of theta. How they are related? So they are not are they supplementary angles? How do I understand that these angles are supplementary? I add them. If the sum is 180, they are supplementary. If I add them, this. But here, if I add them, it does not become 180. It becomes 180 plus 2 theta. Yes.
They are opposite.
Why?
Well, I can't answer it algebraically, but I'm envisioning it in
Yes,
my
that's
mind.
correct. So you did it geometrically, but
Yeah.
let us do it algebraically to combine these two formulas together. Yes? This formula... okay, so can you tell me what is the complement, what is the supplement of this angle? Now, what's the supplement of this angle? You need to think of an angle whose sum with this is 180. So what's this? What? Yes?
Minus theta.
Minus theta. So minus theta is the supplement of this angle. Yes? But we just learned that sine of 180 plus theta and sine of minus theta. If I ask you how these angles are related, you would say that these two angles are supplementary since the sum is 180. Yes? And we just learned that if I have supplementary angles, the sines are equal. So the sine of this is equal to sine of that. Is that understandable? But we just learned what happens for negative inside the sine. It goes out. So I combine these two formulas. So this is an algebraic way of coming without any visualization. Yes. So we realize that sine of 180 plus theta is equal to minus sine theta, combining this formula and the previous formula. Okay? Understandable? Yes or no? Another way to see this problem. This formula only works if this sign is negative. Unfortunately, I have the wrong sign here. So what do you suggest? This is a general technique. This is positive. I don't like positive. I like negative. So what should I do? Yes?
You can make it negative and then make the other one
Negative.
positive.
Negative, negative. So these are standard tricks, learn them. Yes, these are simple. Yes, so it becomes sine of 180. Instead of positive theta, do you agree I can write minus theta? Is that understandable? Yes? But now, if you don't mind, let me call it capital theta, for example. And then you see I have sine of 180 minus capital theta. And I know what the answer is. The answer is sine of capital theta. Yes? But what is capital theta? It's minus small theta. And then sine of minus theta is minus sine theta. So you see, this is a valid argument. This is a valid argument. What actually Kevin Am I right? Your name Kevin? Yes. So what Kevin said, that's also correct. That's coming from visualization. Yes? Any questions here? Yes or no? Okay. Now, there is something missing in the book, and I want to add that, and that is called the trigonometry of complementary angles. And that's extremely important. I don't know why they have missed this. Might be, you can, of course, you can always find them using this technique of visualizing this unit circle, but it is better to have it somewhere in your, somewhere in your memory. So I would write trigonometry of complementary angles. Yes? Okay, first of all, definition. What do I mean by complementary angles? Okay, two angles, alpha and beta, let me write it. Angles, alpha and beta, are called complementary if alpha plus beta is 90 degrees. So that is the definition of complementary angles, and we say that one of them is a complement of the other one. Exactly as before. For example, 30 degrees and 60 degrees. They are complementary. Or, for example, 15 degrees and 75 degrees. They are complementary. 105 degrees and minus 15 degrees. They are complementary. In general, what is the complement to theta? What is complement to theta? It's 90 minus theta. Yes? Okay, so these are pairs of complementary angles. So in general, I want to ask you the same question, but instead of 180, I want to have 90. And this is also very important, at least to know how to find the formulas if you forget. So my question is that, what can I write in front of this? What can I write in front of this? And then, of course, what can I write in front of this? Okay, now the first thing is just going back to the unit circle. Try to discover it once and write the formula there. As I clean the board, you can think about it in your head or on the paper, of course. Okay, any ideas? So my question is that how this guy, sine theta, sine 90 minus theta is related to theta itself. So we should visualize it, yes? So this is my unit circle. These are the coordinate systems. This is the coordinate system, and assume that this is theta. For example. And then let me call this point x and y. Okay? So you need to know where 90 minus theta would be. So if I start from here and go up to this point, this is 90. But this is smaller than 90. 90 minus theta. Yeah? So I need to stop before reaching to 90. But how much before? exactly theta degrees before. Yes? So it means that I need to start rotating about O, but I have to stop somewhere here. So this angle should be, from side's point of view, this angle should be theta, but then this angle would be the angle that I am interested in. This would be 90 minus theta. So what I need to do, I want to read the coordinates of that blue point if I give you the coordinates x and y of the black point. So what are the coordinates? Yes, Jonathan? You interchange x and y, exactly. So this becomes y and x. Is that understandable? Yes, why is that? Because when you say that this is x, it means that this, if I draw a vertical line here, first of all, I hope that you agree with me by symmetry argument that this triangle that you see here, this is theta, this is 90, this is 90, this is theta, and so this means that these two, and that, by the way, the hypotenuses are the same, they are the radii of the circle, so these two are the same, are congruent actually, this is the technical term. So then it means that the length here is exactly equal to the length here. Yes? And the length here is exactly equal to the length here. But we know that this length is x, this length is y. Okay? Here, this length, if I ask you what that is, it is x. What that length is y. Yes? But if I ask you what is the x coordinate of this, you will show this length as the x coordinate. But this length is y. And if I ask you what's the y coordinate of this, you will show me this length, which is x. So that's the reason that they are interchanged. They are swapped. Is that clear? Okay. Now, if I ask you what is the sine of 90 minus theta, you answer me according to the coordinate. What is which coordinate you choose here for this? No? The y coordinate in this case, which is x. Yes, so this is nothing except x. But x itself is cosine of theta. Is that understandable? Yes or no?
Yes.
Okay. So this means that sine of 90 minus theta is not related to sine of theta. It is related to cosine of theta. So this becomes cosine of theta. Yes, it's extremely important, this rule. Yes? If you haven't understood, let me repeat it here. If I ask you what is cosine of 90 minus theta, you need to go and find the end point corresponding to 90 minus theta and read its x coordinate. 90 minus theta, the point is the blue point. I have to read the x coordinate of that blue point. But the x coordinate of that blue point is y. So this is y. Yes? But if I ask you now, forget about this and look at the black point. If I ask you why, how y is related to theta, you say that y is the y coordinate of this point, so it is sine of theta. So, complementary angles have this nice property. Sine of one of them is equal to the cosine of the other one, exactly, and vice versa. Is that understandable? But for tangent, what can I say? Tangent of 90 minus, let me write it here. If I ask you what is tangent of 90 minus theta, what is your answer? You go here, you divide the x coordinate by the y coordinate. If I ask you what is tangent of theta, you go here, you divide the y coordinate by the x coordinate. So these two numbers are not equal, but they are reciprocal of each other. Yes? So it means that tangent theta, tangent 90 minus theta is 1 over tangent of theta. Yes? Is that understandable? So this is a little bit unusual formula. So this is why you have to be very careful, okay? So it becomes 1 over tangent of theta. Because one of them is, for example, 2/3, the other one is 3 over 2. 2/3 and 3 over 2 are reciprocal of each other, yes? Is that understandable? Okay. And there is a name, unfortunately it is absent in your book. 1 over tangent is called cotangent. Okay, so let me just write these things. This is not in your book. I will not give you questions using this, but it is very good to know about this. So cotangent is 1 over tangent. So let me put semicolon, its definition. Yes? Yes? Do you have questions?
Can you repeat that?
So 1 over tangent has a name in trigonometry, even though it is not in the book.
Okay.
It's called cotangent. And this is the symbol we use for cotangent. Cotangent of theta is defined to be 1 over tangent of theta. Okay? And of course, if you want to, it's cosine theta divided by sine theta. Is that understandable? Because tangent was sine divided by cosine, so cotangent would be the other way around. And now that we are talking, so we can say that if you want to, in some books, university books, you don't see this formula, you see this formula. So tangent of 90 minus theta is equal to cotangent of theta. And the cotangent of theta would be tangent of, cotangent of 90 minus theta would be tangent of theta. Okay? And now that I am talking about cotangent, let me talk about the other things. We have cosecant and secant. So it's better to know this. So secant of theta is just a fancy name we just write for 1 over cosine theta. So it's called secant of theta. It's good to know them. And cosecant of theta, it's 1 over sine theta. So these are the only things that you will face. Sine, cosine, and tangent, which is already in the book. Cotangent, secant, and cosecant. I've just given you as an extra information. It's good to know about them. Of course, in the university, you always start working with cotangent, secant, and cosecant. They would be very important. Okay? Okay, so is that understandable? So let me, because this is so important, if you don't mind, let me write this as a regard for you. Sine of an angle is equal, let me write it in words, is equal to the cosine, the sine of an angle, so let me, the sine of an angle is equal to the cosine of its complement and vice versa. It's important to remember this as a sentence, as a rule. The sine of an angle is equal to cosine of its complement and vice versa, meaning that the cosine is equal to the sine of its complement. Yes? Yes or no?
Yes.
So for example, sine of 30 degrees is equal to cosine of 60 degrees. Okay? Cosine of 15 degrees is equal to cosine of 15 degrees is equal to sine of 75 degrees. I don't know, sine of 105 degrees is equal to cosine of negative 15 degrees. But cosine of negative 15 degrees is equal to cosine of 15 degrees. So you see, you can explore these things without actually using the unit circle anymore. So for example, let me write it here for you. So cosine of 100, so let me, okay, I start from here. This is a different example. Cosine of 150, if you want to, I'm not saying why this is useful to write that, no. If you need it somewhere in your problem, if you want to, you can replace this with sine of minus 15 degrees. It's understandable for everyone. If someone asks you why this is correct, because you see that this one and that one are complement, so according to this rule, cosine of one of them is equal to the sine of the other one. But now, what can I do with this negative sign inside the sine? we just learned in the beginning, I can pull it out. So it becomes minus sine of 15 degrees. So you need to be very comfortable with these kinds of calculations immediately. Yes? Okay. Okay, I think, let me now ask you some questions and then we are done more or less for today. I thought in the beginning that you are very lucky to start with math today. Now I think the good sentence is that how unlucky I am that I start math with you today because you are yawning, yes? You are not excited yet. Yes, that was the most correct sentence that I could say in the beginning. Okay, so now let us ask you one question. What is this one? Yes, what is that? 1. Yes? So this is 1. What is this? Both of them are sine here. Yes?
So sine of 75 should be cosine of...
Exactly, thank you. So I would copy and paste the first part, so it becomes sine squared 15, but the remark is still there, yes? Sine of this angle can be written as cosine of its complement. So instead of sine of 75, I can write cosine of 15. So it becomes cosine squared of 15, and then what is the answer to the blue one? It's 1, yes? Okay, now let me ask you this question. What is the exact value of tangent of 15 multiplied by tangent of 75? Even though if you ask me what are these, I don't know. But what is the product exactly? It's 1. Why? Who said 1? Yes, why?
Because tangent of 75 is equal to 1 over tangent
Of 15. They are reciprocal. Yes? If two angles are complement, tangents are reciprocal with respect to each other. So if I have two reciprocal numbers, one of them is 2/3, the other one is 3/2. If I multiply them, what happens? What happens? It becomes 1. So the answer is 1. Yes? Is that understandable? So these are the things that you need to know if you want to solve a little harder problems. Is that clear?
Yes.
Okay. Now let me ask you one question. Can you visualize what is the value for tangent of 45 using the unit circle? That's a different story. What is the value? I will come to this later. I started with the unit circle and then I will teach you the trigonometry, not teach you, having a recap about trigonometry in the right angle triangle. But for the time being, can you tell me, using the idea of the unit circle, what would be the exact value of tangent 45 degrees? Yes?
Yeah, it should be 1.
Okay, why?
Because the x value and the y value...
For the 45 degrees are exactly the same. 45 degrees is the bisector, yes? So I have here, if I ask you show me 45 degrees, of course, you will try to draw the bisector of this 90 degrees. I've split it into exactly half. Of course, my picture is awful, but this would be 45 degrees. And then, if I ask you, do you know the coordinates? You might say no, but you know something. If the coordinates are x and y, what happens, do you think? The value for x and the value for y are the same. Agree? Because this is not only a right angle triangle, but it is also an isosceles triangle. So these two are the same. So now if I ask you what is tangent of 45 degrees, what's your answer? It's y coordinate divided by the x coordinate, but these are exactly the same numbers, so it becomes 1. Yes? Now, I want you to answer this question. Okay, logarithm of tangent of 1 degrees in base 5, okay, plus logarithm of tangent 2 degrees in base 5, and then we continue up to logarithm of tangent 89 degrees in base 5. Without calculator, calculate this. So what's the answer? I want to pause the video for a while so that I can give you time to think about it, okay? Any ideas? I give you a hint. Forget about this problem momentarily. Just try to solve this problem first. Multiplied. Multiplied this. Okay? If you can solve this problem, then going from here to there, it would be just one more step. So if that's a little bit hard because I've seen logarithms here, forget about that. You might haven't the formulas of logarithm in your head. But try to solve this problem. That's not hard. That's not hard at all. Okay? Yes, do you want to say something, Kevin? No, but this is not hard, by the way. You have everything on the board right now. Yes, I think, except one thing that I cleaned there. No, don't use your calculator.
No, I for that one, I tried one thing.
Okay. So do you have any idea? Anyone? Any idea for the second one or for the first one?
Use the one.
So A-level questions are of this type, by the way, in Math 4, so you need to be careful.
Tan 1.
Yes, why?
Tan 1 and tan 89 are complementary angles.
So the product is 1. Then
that's times tan 2 times tan 88.
it's again complementary, yes, so it becomes 1. What is left over at the end?
1.
No. What one angle is left? Because there are 89. So if you group them in group of 2, there would be 1 left. What is that 1 left? Yes? 45. And tangent 45, there was a reason I asked you this question. Tangent 45 is 1. So it doesn't matter. So this product is 1. Is that understandable? Let me just explain it again. So if you want to answer this question, you can arrange them in this order. I hope that you immediately understand there is no difference of how to multiply them. So, do you agree with this equality that I have written on the board? So I have started to grouping the first one and the last one, putting them next to each other, because that's a product. It doesn't matter how you multiply them. Yes? If you want to multiply them one after the other, it doesn't work. But if you think a little bit wiser, you can group them in the group of 2, and then you can multiply them in this order. But of course, it is clear because there are odd number of angles from 1 to 89. There are 89 angles. So if I group them to 2, there would be 1 left. And it's clear, it's not hard to see that what is left is just 45 degrees. Is that understandable? So, if this blue line is exactly the same here, arranged in a different order so that I can manage to solve. And then, what was the goal? Because each pair of these angles, I have been chosen them wisely to be complement. And I just told you, if 2 angles are complement, the product of the tangents is equal exactly to 1. Yes? So this one is definitely 1 because 1 and 89 add up to 90, they are complement. 2 and 88 add up to 90, they are complement. So the product of tangents is 1. Yes? And the same story here. 44 degrees plus 46 degrees is 90 degrees. And so the tangents are equal to 1. And then individually we learn that tangent of 45 degrees, completely unrelated to this topic, it's equal to 1 itself. And then you have a bunch of 1s that you are multiplying. Is that understandable?
Yes.
So this answer definitely becomes 1. But what is the answer of that question mark then? Of course, if you have forgotten the rules and formulas for logarithm, probably you will not be able to solve that. But if you remember, one of the most famous formulas for logarithm is that the sum of the logarithms is equal to the logarithm of multiplication, the product. So we have, if I have a log of x in base a plus a log of y in the same base, if I am adding them, I can write one log in the same base, but instead I multiply them. So if you have forgotten this formula, there were no hope for you to solve that problem, okay? But now that I told you, can you tell me what's the answer to the question mark now? What? 0. Yes, why is that? Because according to this rule, what can I do? According to this rule, I can write this question mark is equal. I can write log of 5, and then I should write tangent of 1 degrees, not plus, multiplied by tangent of 2 degrees, multiplied up to tangent of 89 degrees, yes? But we just learned that this product, according to this calculation, is 1. So this becomes log of 1 in base 5. And I think it's not hard to answer. What is the log of 1 in any base? It is equal to 0. Why? Because 5 to the 0th is equal to 1. So the answer to this is 0. Okay? And for these kind of questions, Indians have only 90 seconds to answer. Yes? So yeah. So you need to know that this is possible. It's not hard. But you need to train your brain. Okay? Any questions here? Is that understandable? So, I don't know what else I can tell you. Let me just see that if I haven't forgotten anything. Actually, let me just finalize this and then we are done. Okay, so I know that you are tired, but you need to actually tolerate that. So, I want to go back to the trigonometry of the right angle triangle, which is probably famous for you and you already know that. But the reason that I managed to talk about trigonometry in this way, I want you to see that this is a unique trigonometry. It doesn't matter trigonometry here and then forget about this trigonometry here. Because usually in lower classes we learn about trigonometry in the right angle triangle, and then we say that, okay, now we are more advanced, let us forget about that, let us work in trigonometry in the unit circle. Might be you think that they are two different things, but they are not. They are exactly the same thing. Okay? So now, I want you to follow this rule, and you yourself should be able to discover the formulas of trigonometry in a right angle triangle. So do you have something in your memory? If you had something in Math 3C, what was sine of an acute angle defined? How was sine of an acute angle in a right angle triangle defined? Do you remember? Yes? Opposite side divided by the hypotenuse. And now we are saying, so apparently they are not related at all. That is something else. That is something else. But I just want to show you that they are exactly the same thing. Okay? So let us see why this is the case. It's extremely important. So we do not have two sines in different contexts. We have one unique sine for each angle. Okay? So my question is that I give you a right angle triangle. I give you a right angle triangle, whatever you like. So this angle, let me call this angle theta, and let me call this side, this is A, B, C, and then you know that this is little b, this is little a, and this is little c. I ask you to calculate for me somehow what is this. I am not asking you to define it for me because I have already defined what the meaning of sine is for you. I cannot ask you to define it again. You understand? The people who are actually very interested in logical arguments, they should actually understand that. So I cannot say what is the definition of sine. The definition of sine is the same as I defined you in the unit circle. So using that idea, you should understand what is the sine of this angle. Okay, so how should I do that? I draw a unit circle. I draw a unit circle here, and I So let me be more careful here. So I draw a unit circle. So can you help me, guide me through it? So you see I have a random right angle triangle. I don't know anything about the size of these sides, anything. But I know this angle theta. Assume that I know these sizes. I want to calculate sine of theta for this using the unit circle, which is the only tool in our hand. So what should I do? What is the first step? Yes?
So you do opposite.
No, you do opposite is coming from your memory. There is no notion of opposite to the hypotenuse. Why is that? Sine, I define sine for you in the unit circle. I cannot again, let us say that forget about all the things that I have said so far and let us now define sine again in the right angle triangle. Because when you punch sine of 30 degrees, the calculator will give you one answer. The calculator doesn't care about if you are thinking about the unit circle or thinking about the right angle triangle. Actually, the calculator doesn't care about these things at all. Okay? So what I'm trying to say, I want you to understand, of course you are right. What we will get at the end should square with our intuition from the previous lesson. So you already know what would be the result. Sine of theta should turn out to be b over a. This is what you are going to get. But this is no longer a definition. I want you to understand that, okay? If you are not interested in these things, you can just simply forget about that and assume that whenever I have this, that's the definition. When I have this, that's the definition. But that's a very wrong logic in mathematics, yes? I have one sign. I should apply it in different contexts. I should give the same result if I am doing everything correctly. Okay, so what is the first step then? Yes? Okay, there is a problem with that. You are very close, but it's not practical because this is a unit circle. Do you understand? So, but there is no guarantee that the sizes are unique, with unit length. It might be much bigger or much smaller. So it might happen, if you are very, very lucky, yes, you will get something exactly fits in this circle. But it might happen that it is much bigger or much smaller.
Circle.
No, it's not possible. I'm just answering. So that's not okay. You are getting close. You understand what's going on. But what I am saying, I cannot just put this here because I don't know. It might be in this picture. You see, this is much longer than the radius here. But you are getting close. Yes, Ruben?
You draw the angle.
You draw the angle. This is the first thing to do. You draw the angle theta, and this is not under your control anymore. It will go and intersect the unit circle at some point. Is that understandable? So what I do, I take my protractor, I measure this angle, and I separate this line in a way that this angle becomes exactly equal to this angle, but I do not have any control on what will happen. This will intersect the unit circle at some point. Let me call it D. And there is no guarantee that from O to D, which is 1, is exactly from B to C. Yes? But what? But I will do this. If I ask you what is sine of theta, so let me draw this vertical line. Is this right angle triangle the same right angle triangle there? In general, no. There is no guarantee for that. But in general, there is a relation between this one and that one. I am looking for the correct word from you. They are similar. They are not necessarily congruent. If I am lucky, they become congruent. Life becomes easier. But if I am not unlucky, usually we are not lucky. So then this will happen that this triangle is similar to that triangle. Why is that? Why this triangle inside this unit circle is definitely similar to that triangle? Yes? Exactly. Because two angles are the same. 90 degrees is 90 degrees and theta I made it myself. So 2 angles from one triangle is equal to 2 angles from the other triangle. So these 2 triangles are similar, according to angle-angle theorem, yes? So then what does it mean? So let me call this y, let me call this x. If I ask you what is sine of theta, can you answer me in this context? That's the only context we know. What is sine theta in this picture? Y, it's y. Exactly. Agree with me? Now, let us go back here. Do you know that this triangle is similar to that triangle? So it means that whatever b over a is equal to, can you tell me what from that circle? Because b over a, because the ratios should remain the same, b over a is equal to y over 1. Why 1? Because 1 is actually the radius. And what this becomes y. What is y? You told me just now. Y is sine theta. And now look here and there. You get your formula back. Okay? So is that understandable?
Yes.
So you see, I define sine just in one way. The consequence of this definition in the context of a right angle triangle would be the same thing that you knew before. But the logic is quite different for the people who are interested to understand things in a correct way. So we do not have 2 trigonometries. One trigonometry in this context, another trigonometry in that context. We have only one unique trigonometry, and that is trigonometry in the unit circle. But if we apply the same concept in this new context, we get something easier. Why this is good? It's because we are working with this right angle a lot, so it is good. Do it once for all and remember the formulas. But the logic was completely upside down when you learn it in Mathematics 3C, for example. Yes? Is that understandable? So now let me go back and just write these things for you. So sine of theta is what? Is b over a. What is cosine of theta, do you remember? C over a. And what is tangent of theta? B over C. Yes. So opposite to the hypotenuse, adjacent to the hypotenuse, and opposite to the adjacent. So these are immediate consequences of what we already know about the unit circle. Is that understandable? Okay, so now I want now to calculate 2 more things for you, and then we are done, okay? I don't know we are done or not. Let me go, let's see how it goes, yes? So now there are some famous angles in trigonometry, yes? So, so you need to know these angles are 30, 45, and 60. These are really famous angles. Why they are famous? Because we can calculate sine, cosine, and tangent of these angles exactly without using calculators or whatever. These are one of those angles that we can do that. Okay, so for 45, we already did it, yes? For tangent, we did. But let me now, if I want to do 45, now it is. If I am more comfortable, I work in this context, I know what are the rules here, the same rules applies in this context, or I can go and use that idea. Let me now use this new context. So for 45 degrees, so I want to, let me complete this table for you. This is the table that you will get at the back of the formula sheet. So let me write here theta for you, sine theta, cosine theta, and tangent theta, okay? Some of them, you got them using so 0 degrees, and then 30 degrees, 45 degrees, and 60 degrees, 90 degrees, 180, 270, and finally 360. If you remember, we did all these columns using the unit circle, and we got the answer. So for example, this is 0, this is 1, this is 0, and then we came here, this is 1, this is 0, this is undefined, and then here this is 0, this is minus 1, this is 0, this is minus 1, this is 0, this is undefined, and here 0, 1, and 0. These are the things that we actually practiced a little bit when I introduced you the unit circle. So these are easy. If you go to the coordinates, you can read them. Any questions regarding these columns? Understandable? You find the final point and read the coordinates, yes? But for 30, 45, and 60, I want to complete it today now. You don't need to memorize this, but you need to remember 30, 45, and 60, and these other angles are famous angles. So at least you need to know that they are famous, and if you need them, you should refer to the table. But if you completely forget about these angles being famous, then you will be in trouble, okay? So let me start with 45 degrees. Now, we have two things. If I can work it out in the unit circle, or if I want to, I will work it out in the right angle triangle. So let me just do it in the right angle triangle. So for 45 degrees, I start with a right angle triangle such that one of these angles is 45. If this angle is 45, what will happen for this angle? That's also 45. So what does it mean? It means that the length and this length are the same. Yes? So if I call this one, for example, A, this is also A. So now if I ask you what is tangent of 45, you answer the opposite side divided by the adjacent side. Independent of the value that you choose for A, this value is 1. So tangent of 45, I have this number equal to 1. Now, if I ask you what is the sine of 45 degrees, what's the answer? Sine of 45 is the opposite side divided by the hypotenuse. So let me call the hypotenuse equal to B. Then I will face a little bit of problem here. It becomes the opposite side divided by the hypotenuse. But so I don't know A, I don't know B. Is there any way to know the ratio of A over B? Even though I do not A or B individually. Is it possible to know the ratio? Yes?
Can you calculate B with the Pythagoras?
Yes, Pythagoras Theorem, I use it. So Pythagoras Theorem tells me that B squared is equal to what? A squared plus A squared, which becomes 2A squared. Agree? Then I take square roots. This becomes B. Square root of 2 is the square root of 2. This becomes A. Agree? So then I put it back here. So this becomes A over, instead of B, I put the square root of 2A. So if A cancels out, so what is left is this. So I will put this here. Okay? And I want you to teach some trick for you. In some books, you do not see this number. You see this. Okay? 1 over square root of 2. You can write it 1 over square root of 2 and rescale it by square root of 2 over square root of 2. Do you agree that this equality is valid? I'm just multiplying and dividing by the same thing, so it becomes the same. But what is the benefit of that? So this becomes square root of 2, but this becomes 2. So remember this fact somewhere in your head to be quick. 1 over square root of A is A. So this formula is a nice formula to remember. So this is why I don't remember which one is written in your book. This is written in some books, and this is written in some other books. Yes? And now, do I need to calculate cosine of 45? No, because what is the complement of 45? What is the complement of 45? Is 45 itself. But what was the rule? The sine of an angle is equal to the cosine of its complement. So it means that the cosine of 45 is exactly equal to sine of 45. So which is, you see, I'm using all these rules. It doesn't matter. You can use the rule the same here. But let us use everything to refresh our memories for that. So sine and cosine is here. Okay, let me go to 30 degrees. So for 30 degrees, where should I start? I should start with a triangle. So that one angle is 30 degrees. Agree? So then, let me call this A, let me call this B, let me call this C, and I am interested now in calculating sine of 30 degrees. Okay, sorry. So let me write it a little bit. Okay, so here, you need to be a little bit more creative. Okay? Because if I start from here, what is sine of 30? Sine of 30 is A over C. But I do not have any specific relation between A and C yet. And even if I use Pythagoras Theorem, it doesn't help, In this case, Pythagoras Theorem actually helped because I had two unknowns, A and B. But here I have three unknowns. I don't know the relation between them. So you need to be a little bit creative. So to understand how this goes, what I will do, I will reflect this triangle with respect to this line. So consider the mirror image of this triangle. Okay? Now answer my questions. What do you expect for this angle? It is 30 degrees. And then if this is A, what is this blue line? A. If this is C, what is this blue line? C. Understandable? Okay. Now can you tell me what is the name of this bigger triangle here and why? What type of triangle, sorry? No, more than that. Equilateral. Yes, why is that? Because as you said, it is isosceles because C and C are the same. Yes? But how much is this angle? 60. So what is left for this one and that one? They have to be the same. So they are 60 and 60. So this triangle, this bigger triangle is an equilateral triangle. So what does it mean? It means that this side, what is the length of this side? No, yes. On the one hand, it should be C. On the other hand, it is 2A. So they have to be equal. And that is the relation that I was looking for. I wanted a relation between C and A, and I put it back here. So this becomes A. Instead of C, I put 2A, and this is cancelled, so I get 1 over 2. So sine of 30 is exactly 1 over 2. So let me put this number back here. It's 1 over 2. Under 1 second, tell me what is the number here? 5 seconds. What's that? 1 over 2. Why? Because this is 60. It's complement to 30. So if sine of 30 is 1/2, the cosine of 60 should also be 1/2. Yes? So I don't need to calculate this. This is 1/2. Okay? And now, here, I go back and calculate cosine of 30. So what is cosine of 30? The cosine of 30 is the adjacent side, which is B, divided by the hypotenuse, which is C. Now, I have one relation here. I want another relation between them, but I know that in the original triangle, I can use the Pythagoras Theorem, yes? So what is that? C squared is equal to A squared plus B squared, agree? But C is 2A, so it becomes 4A squared. Instead of C, I put 2A squared, 4 squared is equal to A squared plus B squared. I move it to the other side, becomes negative 3A squared is equal to B squared. And then I take square root, it becomes square root of 3A is equal to B. And then everything is ready. So here, instead of this B, I put the square root of 3 over times A. Instead of C, I put 2A. And now what happens? A and A are cancelled. So I get the square root of 3 over 2. So I will put it here. Okay, 1 millisecond here. The square root of 3 over 2. The same number because they are complementary. Yes? And now for tangent, everything is ready for me. Tangent of, let me calculate tangent in a different, we can calculate tangent is equal to A over B. Yeah, that's good. Tangent of 30 is A over B. Instead of B, I put the square root of 3A, and then I have A, so it becomes 1 over the square root of 3. So tangent is 1 over the square root of 3. What is this number? The square root of 3. It should be the reciprocal. So it becomes this. And what is another name in the box? You see that box there? I can write it as the square root of 3 over 3. Okay? Okay, so now everything in the first few pages of the book is finalized completely. Yes, so you can start working, and I think you have to get used to the way of I teach you, okay? I usually teach a lot, so, but there are some exercises. I will give you the link of all these exercises on Google Classroom. So, yes, everything is finished up to page 16 from the lesson point of view, and you have 2 set of good exercises on page 15 and 16. if you can solve these problems, you don't have any problems, you will not have any problems in the exam, even for getting an A. Okay? So some questions that I solve here are actually harder than the exam, but for the exam, I will follow the level of the exercises in the book. Okay? So that would be extremely important if you solve them. Unfortunately, this book has a complete solution manual for every details. So there are a faucet, forget about the faucet. Faucet is the final answer, but if you look around, I don't know what is the Swedish word for this solution manual. What? Okay, so you can find it somewhere. If you don't know, I can give you the link once, and then you can find it and save it somewhere. Okay? So do not think that you saw. I really recommend you, even if you are confident about your solution, look at least the solution by the author. Yes? It's better because sometimes you think that you have solved the problem and you got the correct answer, but it might be a little bit of coincidence. Make sure that you really understand what is going behind it. Any questions? Okay, and then I am completely free to suggestions, objections, and ever, but it doesn't mean that I will accept your suggestions and objections, but I will definitely think about them. And if I am doing something wrong, then I definitely will change myself, okay? But if you tell me that you are teaching too much, I will not change the method. I will still teach too much. Yes? Yes. So if that's your objection, please don't bother to write me. I will not change that. Okay? Thank you very much.